In this video, we'll talk about scientific notation. So what is scientific notation? It is essentially a way of writing large or smaller numbers. What that means essentially is that in chemistry, we often deal with numbers that are either really big or really small. For instance, if we talk about the diameter of sun, in meters, it is a very big number. It is 13920000000 meters. On the other hand, if we talk about the average diameter of an atom is a really small entity. So its diameter is actually really small. So you can see right here the diameter is 0.00000000003 meters. When we are talking about the numbers that are this small or this big, it usually becomes very tricky to write these numbers out or to copy them or to even remember them, because remembering the place value like 10, 100,000, million, it becomes a little bit tricky. So an easier way to depict or write such numbers is called scientific notation. What that means is that I can simply convert this large number or this small number into something that looks like this. So you can see right here that now that number, instead of including all those zeros, has been reduced down to 1.392 times 10 raised to power 9 meters. Or the diameter, which was a really small number, has been reduced to 3 times 10 raised to power minus 10 meters. So writing numbers like this is a lot more easier, and remembering numbers like this is also a lot more easier than remembering all those zeros. So what is this? This essentially is called the scientific notation. So here we converted those big and small numbers into scientific notation. So scientific notation would always consist of two parts. First part is called the decimal part, which is this number right here, is called the decimal part, which is essentially just a standard number like we write down. Only important thing is that the decimal place here is always going to be after the first number, first non-zero number. So the decimal part is always going to be a number between 1 and 10, never equal to 10. It's going to be either between 1 and 10, so meaning anything between 1 and 9. And this decimal is always going to be after the first non-zero digit. It cannot be a zero digit in front of a decimal. That is called the decimal part in scientific notation. The second part that you see right here is called the exponent part. This whole thing is the exponent part, where we have essentially a power. This portion right here is called the exponent. So we always have 10 raised to power of an exponent. Now this exponent can be positive number or it can be a negative number. A positive exponent means that the number is really big. So for instance, the sun's diameter you saw was 139200000, like really big number. So when the number or the exponent is a positive number, that means the number is a big number. Okay. Whereas when the exponent is negative, for instance, you can see right here, the diameter is a negative exponent. When the exponent is negative, that means the number is a small number. So what happens here, what we did here is that 10 raised to power 9 means that we have to multiply this number 1.392 by 10 9 times. That's 10 raised to power 9. So that means the number at the end is going to be a really big number. Similarly, if we talk about the number at the bottom, which is size of the atom, it is 3 times 10 raised to power minus 10, meaning we are dividing number 3 by 10 multiplied by each other 10 more times. So that would give you a really small number. So a negative exponent means the number is small. A positive exponent means the number is big. And this again tells you exactly what is scientific notation. It consists of a decimal part and it consists of an exponent part. And in the exponent, the power that the 10 is raised to is called the exponent. And this can be a positive or a negative number. Now let's see, when you're comparing the two numbers here, the exponent is very important. For instance, if you're comparing these two numbers, which one is a bigger number? So I have 1.23 times 10 raised to power 5 and 4.56 times 10 raised to power 2. Like I said, a positive exponent means that the number is really big. So here I'm taking 1.23 and multiplying it by 10 5 times. And here I'm multiplying 4.56 by 10 only 2 times, which means if my exponent, first thing you should always compare is the exponent. If you can see the difference in the exponent, then you don't even have to see what the decimal part is. So right here I can definitely see that 10 raised to power 5 is going to be a lot bigger than 10 raised to power 2. Similarly, if you're comparing these numbers, this is 4.56 times 10 raised to power minus 2. This is 7.89 times 10 raised to power minus 5. If you're comparing which one is a bigger number, how can you compare? If the exponent is negative, that means higher the negative exponent or bigger the negative exponent, the smaller is the number. So in this case, this has an exponent of negative 5, 10 raised to power negative 5, and this is an exponent of negative 2, which means negative 5 is a much smaller number. So this number on the whole is going to be a lot smaller than the previous number. And it will make a little more sense when we actually see how we can write the numbers in scientific notation, or how we can go back and forth between decimal or standard number in scientific notation. So let's see how you can actually do this with an example. So I'll show you the rules in a little bit, but let's start with an example. So let's say I have a number 2400, very simple number. I want to convert that into scientific notation. How can you convert that? The first step is you have to locate where the decimal is located. So in this case 2400, we don't see a decimal, which means the decimal is right here. I'm saying this is 2400, right? So that means this is my decimal portion. Now what do you want to do? Whenever we write the scientific notation, remember the decimal is always between the first two non-zero digits. So these are the first two non-zero digits. So I will have to move the decimal place. By how much? I'll move it by 1, 2, 3 places. So now I want to bring my decimal right here. So I have to move it by 3 places, 3 place value, which means I can write this number as 2.4 times 10 raised to power 3. Okay, so I moved it 1, 2, and 3. So that's why this number exponent that you see right here is 3. Now, how did I decide that this is a positive exponent and not a negative exponent? Whenever there are two things that you can see. First is you could memorize this, which I would not recommend, but you could if you are moving the decimal place from the right to the left. The number exponent is always going to be positive number. On the other hand, the easier way to remember is see how the number that was given to us was 2400. So the number in itself is a really big number. And what did we reduce this number down to? We reduced 2400 into 2.4. So we made the number actually small. If you're making the number smaller, the exponent has to compensate for that. So if I'm making the number small, the exponent would be positive. Okay, so if you're making the number small, the exponent would be higher or bigger, because we cannot reduce the number. You cannot just say, okay, I have $2,400 and now I reduced it down to $2.4, right? We would not like that. So if I'm taking $2,400 at the end, I should have $2,400. So you can basically go from 2400 to 2.4, but now your exponent has to be a big number to compensate for that smaller change. Okay. Similarly, let's say if I pick another example, if I pick an example of say 0.00086, okay. Now I want to convert this into scientific notation. The first rule of scientific notation is locate where the decimal is, which is right here, and try to move it to the place between first two non-zero digits. So first two non-zero digits are right here. So I want to move my decimal from here to here. So how can I move it? You go from start counting it the place value that you're moving. So we're going from 1, 2, 3, 4. I moved it 4 place values. So the decimal part would be 8.6 times 10 raised to power. I know the exponent is 4, but is it positive or negative in this case? The exponent would be negative. How do I know that? So you can see right here, the original number was 0.00086. And what did I convert it into? I converted it into 8.6. So basically what I did here is I took a very small number and converted it into a bigger number. If I'm converting small into big, my exponent will have to compensate for it, and therefore the exponent would be negative. Okay, so you cannot convert a small number into a big number. Same thing, right? So we are compensating for it with use of an exponent which is negative. Or you could simply see that if you go from left to right, the exponent would be negative. Or you can just think about this logically that okay, this is a very small number, so I cannot have a very big number. If you have a positive exponent, the number is going to be big. It's a small number, which means my exponent has to be negative. All right, so basically when you're writing the numbers in scientific notation, you're moving decimal places, and we're going to do the exact same thing when we do reverse. So the rules are also listed in the PowerPoint slide. You first locate the decimal point, then you move the decimal point to obtain a number between 1 and 10, and multiply the new number by 10 raised to power n, where n is the number of places you move the decimal point. Now if you move the decimal point to the left, then n is positive. If you moved it to the right, n is negative. Or you could simply remember that if the original number was bigger or large, then n is positive, and if the original number is less, n is negative. Okay, so let's try one more example. So if I have this number right here, which is 12340, I'm trying to convert this into scientific notation. How would we do that? Where is the decimal place right now? The decimal is right here. It's not visible to us, but if it isn't, that means it's right here. So now I want to move the decimal place where? Right between 1 and 2. That means how many places am I moving the number? I'm moving 1, 2, 3, 4. I'm moving the decimal place by 4 place values. So my number would be 1.2340 times 10 raised to power 4. And it's a very large number, which means my exponent would be positive. Okay, let's try another example where we have this. So in this case, we want to write the scientific notation. The decimal is right here. Where do I want the decimal? Between 1 and 2. Again, why? Because we want it between the first two non-zero digits. So how many places do I move the decimal now? I move it from here. 1, 2, 3, 4. That is 4 place values. So my number would turn into 1.2340 times 10 raised to power 4. But in this case, it's going to be negative 4. Why? Because the original number is really small, so my exponent has to be negative. Right? Pretty simple. You can try multiple questions of this form, and I'll give you some practice questions as well in the PowerPoint slide. But first, now let's try to do the reverse of this. So what if a scientific notation is given to us and we want to convert it into standard form? How can we do that? Exact same thing. You're moving decimal places. For instance, I have a number given to us right here. So let me rewrite the original number, the decimal portion of the number, 1.234. The question is telling me it is 10 raised to power minus 6, which means I have to move the decimal places, right? So if I see a scientific notation like this, the exponent is negative, that means the number is a smaller number, right? So now if the number is small, I have to move the decimal places towards the left side, because I will be adding zeros. If a small number means it's 0.000 something, right? So now I have to move this decimal place by 6. How do you do that? You do the exact same thing that we did when we were writing the scientific notation. I take the decimal right here, I move it 1 place, 2, 3, 4, 5, and 6. So decimal has to be somewhere right here. Whatever empty slots that you see right here, just put a 0. 1, 0, 2, 0, 3, 0, 4, 0, 5 zeros, and this 6 0, which means my number is now 0.10235, and then rest is same. So that would be your standard form from the scientific notation. Okay, let's try one more question. So here are some questions that you guys can practice on your own. We can pick a couple examples from here. So let's say we'll convert this and this right here. Okay, let's try these two questions. So if we were to write these into scientific notation, let's pick the first example. Where is the decimal place? I don't see one, so I'm going to assume it's right here at the very end. and we'll move the decimal places. Where do we want the decimal to be? Between 1 and 4. So how many places will I have to move? 1, 2, 3, 4, 5. 5 decimal places, which means this would be 1.45 times 10 raised to power 5 decimal places. And the exponent would be positive because the original number is a big number or a larger number. Okay, let's try the last portion. Oh, how many places did I move? 1, 2, 3, 4, 5. Yep. Let's try this question. In this case, we are converting this small number into scientific notation. So I need the decimal place between the first two non-zero digits. In this case, that is between 8 and 7. I need the decimal right here. So how many places am I moving this? By 1, 2, 3, 4, 5, 6. By 6 place values, which mean my number would be 8.706 times 10 raised to power. In this case, this was 6 decimal places, but it would be a negative 6 exponent. Why? Because the original number is a really small number. Okay, so you guys can try rest of the questions, and the answers are already given to you, and then confirm your answers. Next question, we are trying to go from scientific notation into standard form. Let's try the first question, which is given to us right here. So this number is 2.1 times 10 raised to power 3. Now remember, the first thing you should see is the exponent. You can see right here that the exponent is it's a positive number, which means the number is a large number. Now we start with what number is given to us, and now we have to move the decimal place so that we can get to the standard form. And again, this is a larger number, which means the zeros are going to be on the right side. So I'll move the decimal by 1. I'll move the decimal by 1, 2, 3. Decimal would be right here. Now whatever the empty slots that we see, we can put zeros, which means my number would be 2100 decimal. Okay, now let's convert this number, the second number right here, 9.66 times 10 raised to power minus 4. So if I see that the exponent is negative, that means my number is a small number. So to move the exponent, I have to, if it's a small number, it has to be added, the zeros have to be added on the left side. Why? Because it's a small number, so it is 0.000 something, right? So I'll move the decimal by 4 places. So 1, 2, 3, 4. So the decimal has to be moved right here. The decimal has to be moved right here. Oops. 1, 2, 3, 4. Right here. Now all the empty slots, we are going to put zeros, and the decimal is right here. So the number would be 0.000966. Okay. Now this number right here, whenever you see 10 raised to power of 0 or anything that is raised to the power of 0, that means if the exponent is 0, that means that number becomes equal to 1. So 10 raised to power 0 is 1, which means 4.02 times 10 raised to power 0 is 4.02 times 1, which means it is 4.02. So whenever you see 10 raised to power 0, that means it is 1. Let's try these two questions as well. So if the number is 3.3 times 10 raised to power 1, how would we convert it? Which means 10 raised to power 1, it's a positive number, so it's a large number. So I have to move this decimal place towards the right, because I will be adding zeros in the right side. So I'll start from here. I just move it by 1 place, which means the decimal is going to go from here to here. So the number would be 33 or 33 decimal. Okay. Now if you look at this example, 6.04 times 10 raised to the power minus 2, it means negative exponent, which means the number is a small number. So now I have to move this decimal place towards the left. I have to add zeros in the beginning. So I start from here, I move it by 1, 2. Decimal would be right here. Fill this up with 0, which means the number would be 0.0604. That would be a final number in standard form. Okay, so you guys can practice more of these questions in the practice worksheet, and that is all about scientific notation.